All right, it's Thursday, and tomorrow you get a work day on all of this homework. Don't forget, it's not due until Sunday at 9 o'clock at night. So Friday, we just wanted to give you a little bit more time to work on your assignments and stay up on your lessons. So today we're going to be looking at Arithmetic Series. So I'm going to tell you a story. A long, long time ago, in a land far, far away, there was this little boy whose last name was Gauss. He was in a one-room schoolhouse, and one-room schoolhouses, they had everybody from kindergarten all the way through high school in there, and he was probably in the third grade, I would assume. And so the class was being really rowdy, and the teacher, she had all these kids in there, and she had just had it. So she was at the front of the room, and she said, "Okay, everybody, stop what you're doing. You're in trouble. I want you to write from 1 to 100 on your slate board." A slate board was probably a little bit smaller than a piece of paper, and it was chalk, and you know how bulky chalk can be. And she goes, "I want you to add up the numbers from 1 to 100. Nobody talk. Nobody get up until you're done." So the teacher went to the front of the room, sat down thinking, woo, I'm going to have at least a half hour to an hour of peace and quiet while the kids just do busy work. But she did not realize she had a genius upon her. And this little boy, whose last name was Gauss, within minutes came up to the teacher with his slate board and said, "Here's the answer." And she's like, "Ooh, I didn't even figure it out." So she goes, "Well, what did you do?" He goes, "Well, I did not have enough room to write all the numbers down. So I did this." And he said, "Then I looked at it for a second, and I noticed that when I added the first and the last, it came up to be 101. And then the next and next to last were 101. And the third and third from the last added up to be 101. So I had 101 50 times. Now you're thinking, oh, third graders do not know how to multiply, but you got to remember, he had been watching some of the older kids in their lessons, so he did know how to multiply. And when he multiplied, he got the number 50-50. So this little boy, way back when, came up with your next formula. So get your formula page out to write it down. This is the partial sum of an arithmetic series. And the reason they say partial sum is if a series goes on forever and you're adding the same number or subtracting the same number over and over and over again, you can never get an exact value. So I have to say, find the sum of the first 10 terms, find the sum of the first 50 terms. So n is the number of terms that you have. Notice it's here and here. This is the sum of the first 10 terms, so that'd be S sub 10. This is your number of terms. This, of course, is your first term, and here's your last term. So go ahead and pause the video to write this down on your formula sheet. You're going to want that formula sheet. All right, getting back with it. Here we go. It says, find the indicated sum for each arithmetic series. So what do I need? I need my first term, I need my last term, and I need the number of terms to find the sum. So to get your first term, you're just going to put in a 1. 3 plus 4 times 1 is 7. To To get your last term, I have to look up here and see what term is my last term. That's the number of terms also. So that's 15. And I'm going to have to do 3 plus 4 times 15, which turns out to be 63. So now we're ready for our formula. S sub n equals n over 2 times your first term plus your last term. So S sub 15 equals 15 over 2 times your first term, which is 7, plus your last term is 63. So S sub 15 equals 7.5 times 70. So the sum of the first 15 terms is going to be 525. So as long as you have these 3 items, you can always find the sum. Okay, this next one's written a little bit differently. So this 20 here lets me know that, oh, whoops. Okay. A sub 1, A sub n, and n. What's going on here? Okay. Put n up here. So this right here tells me how many terms. 20. Here is my first term, but I do not have my last. So if you do not have one of these 3 items, you're going to have to use your arithmetic explicit. A sub n equals A sub 1 plus n minus 1 times d. So we have A sub 20 equals 2 plus 20 minus 1 times, do I know my common difference? I sure do. My common difference is 3. So A sub 20 turns out to be 2 plus 19 times 3. And we get, what do we get for that? A sub 20 turns out to be 59. So now going back here, I know that my last term is 59. S sub n equals n over 2 times your first term plus your last term. Here we go. The sum of the first 20 terms is going to be 20 divided by 2 times 2 plus 59. S sub 20 equals 10 times 61. So S sub 20 equals 610. That's the sum of the first 20 terms. All right, let's look at this next one. On this one, we're finding the value of n. It's in summation notation. When it gives you what it equals, that's your S sub n equals 990. Okay, so I do not know my number of terms. We got to find our first term. And we got to find our last term. Okay, so to find my first term, I'm going to put a 1 in here. 6 times 1 minus 2, which equals 4. So my first term is 4. Next, I need to find, I know my sum is 990, and A sub n is 6n minus 2. So let's look at our formula. S sub n equals n over 2 times your first term plus your last term. So let's put everything we know in. So 990 equals, I don't know how many terms. I do know my first term, plus my last term is 6n minus 2. 990 equals n over 2 times 6n plus 2. And then I can take 2 into that. So 990 equals n times, if I take the half of everything, 3n plus 1. Which gives us 990 equals 3n squared plus n. Since I have that, I have to bring everything over to the same side, so subtract 990. Zero equals 3n squared plus n minus 990. I'm going to continue that over here. What we can do here is we can factor. Three n squared is a 3n and an n. Now you're going to have to find all the factors of negative 990. Remember, you're going to have one positive and one negative. That adds up to be 1. So if I put a plus 55 here and a minus 18 here, it gives me 55n and negative 54n, which this is it. So now 3n plus 55 equals 0. 3n equals negative 55. N turns out to be negative 55 thirds. Can you have a negative number of numbers? Nope. So then n minus 18 equals 0. So n equals 18, and there is our number of terms. This one is a little bit more difficult, so you might have to go through it a few more times, but look at your notes. All right, I believe that this is our last problem. It says find the sum. So I know my first term is 3. My common difference is 3, and my last term is 210. So what are the 3 things I need to find the sum? I need the number of terms, I need the first term, and I need the last term, which I have 2 of those. So if I don't have one of these, I have to go back to a sub n equals a sub 1 plus n minus 1 times d, and I need to find that n right there. So do I have my last term? I do. It is 210 equals 3 plus n minus 1, and my common difference is 3. So 210 equals 3 plus, distribute, 3n minus 3. 210 equals 3n, divide by 3, and n turns out to be 70. So now I do have that. Okay, we're ready to find our sum. S sub n equals n over 2 times your first term plus your last term. So we're finding the first 70 terms. So it's going to be 70 over 2 times 3 plus 210. S sub 70 equals 35 times 213. So the sum of the first 70 terms turns out to be 7,455. So remember, if you do not have one of these values to go into your sum, you have to go back to your explicit formula and find it. All right, so what is the formula for a arithmetic sequence? A sub n equals a sub 1 plus n minus 1 times d. What is the formula for an arithmetic series? S sub n equals n divided by 2 times a sub 1 plus a sub n. Okay, so my thoughts are you need to write down these formulas and know what each means. Okay, your assignment is big ideas, 8.2b. Don't forget, ask your teacher questions. And tomorrow is a work day. You can work on all of your assignments. You have all day